This Centerlock hub and upright, along with these H&R coilovers, are going to be the foundation of the suspension on our F40, but you can probably tell these are not original F40 equipment. In fact, this is off of a modern Ferrari Challenge race car. We're going to be using this as well as all of the rest of the pieces and the suspension geometry so that our F40 handles better than any F40 ever.
This week, we're back on the F40, and today we're focusing on suspension. We're not going to be doing any fabricating, but we're laying some very important groundwork so that this F40 is unlike anything that precedes it. If you're new here, this is a one-off, one-of-a-kind tube chassis F40 that utilizes original bodywork along with a Ferrari Enzo-derived V12. But for the suspension, I want to explain exactly why we're taking this approach, and for that, we've got to rewind all the way back to 1987 when the Ferrari F40 was originally introduced. Now, I want to preface any criticisms about the F40 with the fact that I hold a lot of reverence for this machine. It's one of my all-time favorite cars, and it has earned its place in the history books. It is, without question, one of the best Ferraris or even best cars ever produced. But a lot of the praise that surrounds it is fueled by adoration and romance. Today, the F40 is nearly 40 years old, and cars have evolved a lot since then. But what's important to point out in this case is that the chassis was already nearly 20 years old in design when the F40 was introduced. To the untrained eye, the chassis itself is almost identical to the original Dino 246, which was introduced in 1967. That's not to say that there aren't differences between the two, and there is 20 years of evolution between them, but it wasn't cutting-edge technology at the time. And that's not to slight Ferrari. This car had to be built and it had to make sense. And to be clear, the Dino 246 was ahead of its time, so the F40 is, again, a great car. But there's room for improvement. Why would we replicate a 40-year-old car with 60-year-old technology if we could just make something better? But I think that we could do that with reverence for Ferrari still. I want this car to be a Ferrari at heart when it's finished, and that's why we're turning to Ferrari's Challenge Car program, which was originally introduced all the way back in 1993. The Ferrari Challenge competition was introduced as a way for 348 owners to take their cars racing, and thus the 348 Challenge model was introduced as well. These cars were largely similar to their road-going counterparts, although they were fitted with a few different changes such as alternate brake pads, roll cages, slick tires, and other subtle nuances. To be clear, they were dedicated track cars not meant for the street, but as a result, if you're asking me, these cars represent the purest form of these models in contrast to the street cars. The successor to the 348 was, of course, the 355. As a result, the 348 Challenge evolved into the 355 Challenge, a car that a lot more people are likely to be familiar with, if only thanks to the classic video game that shares its namesake. Following the 355 is the 360 Challenge, and then the F430 Challenge. Those mark the end of the classic Challenge cars and bring us into the modern generation with the 458. Yes, the 458 Challenge is 15 years old at this point, but as we're going to touch upon here in a minute, its architecture represents what Ferrari is currently using. Many enthusiasts herald the 458 itself as the last truly great driver's Ferrari for a number of reasons. Its naturally aspirated V8 platform is truly incredible, but the chassis dynamics are also what you might say as good as it gets, and that's why Ferrari has continued to build from it.
So as you've probably already guessed, that brings us to the parts that we have right here. These are off of a 458 Challenge EVO race car. There are around 50 of those built. How many are left, I don't know, but we've got the running gear off of one, and it's going to be the foundation for everything that we're using on the F40. And what I think is really cool about these parts is that although this stuff is about 10 years old, It represents Ferrari's current modern technology. Basically everything built from this point forward is interchangeable across basically every car Ferrari has built. This is essentially the same as what you'd find under a 296. We are going to have absolutely state-of-the-art modern Ferrari suspension technology, making this F40 handle unlike anything before it.
What we have here are the front and rear uprights from the 488 Challenge EVO. The front spindle has had a number of slight revisions through the years, but the rear upright is literally identical when it comes to pretty much everything Ferrari has built in the last decade. This thing can be found on the 458, the 488, the 812, the FF, the F12, the California. Basically, if you can name it, Ferrari has put it on a car. I like to think that Ferrari would say, don't fix what ain't broke, and that's why we're here today. The primary difference between these parts and the road-going parts are the Centerlock hubs that are attached to the uprights. Given that the original F40 and LM are Centerlock, this was the only option for a project like this. These are also going to allow us to pair our car with some crazy huge modern brake options. We could of course use parts off of the factory Challenge car, or we can pair it with something aftermarket. I've yet to decide entirely. But the uprights on their own aren't a ton of use to us. We need something to go with them.
Luckily for us, these should be the last pieces that we need for this puzzle. Now what we have here are the factory control arms from a 458 Italia. This is the left-hand side of the car. We got a rear lower control arm, the upper link for that, and then we've got the upper and lower control arms for the front, all one side. Obviously, this is factory stuff. Is this what we're gonna use? I don't know yet, I gotta decide. There are some upsides to this and some downsides to this. The main thing is gonna be that we have these and we are going to copy the geometry. Ferrari got this stuff right. These cars drive awesome. There is no reason to reinvent the wheel. And there's a lot of similarities between how an F40 is laid out and how a 458 is laid out. We're gonna transpose all of this stuff onto our car. And if we remake these control arms, we're not gonna go customizing any of the geometry. We're gonna copy what's here and maybe just make it so that we can use spherical bearings or different ball joints or what have you. Maybe make some of it adjustable if we wanna adjust camber or caster, but otherwise, Ferrari did the work already. We're not reinventing the wheel. As far as the upside to using this stuff, it's well built, it's available off the shelf. If we want replacements, we can just buy it, although it is eye-wateringly expensive. This is used stuff, and this right here was like $1,500. So, have some decisions to do, but let's go and assemble some of this stuff here on the workbench and check it out.
If you're an OG fan of the channel, chances are you remember the 244 GTK control arms saga, and that's not something I'm eager to repeat again. I learned enough through that process, and that's why we're going to copy Ferrari's homework by utilizing these control arms. Now, as said, I don't know if I'm just going to use these control arms as they are, make mounts and bolt them to the car, or if we're going to fabricate some that replicate them. Now, regardless of which I decide, these control arms will bolt onto the car and work either way. That's why we have them, and we can begin the design process by using them. Now, there are some other variables that we're going to cover here later in this episode and in another one that's upcoming, but the idea is simple. The running gear of this car will be a 1-to-1 perfect replica of a 458 Challenge EVO. We're going to mess with track width just a little bit because there is a big difference between an F40 and a 458, and we're also likely to have a slight difference in scrub radius due to some of the work we're going to have to do on the front end and as we choose wheel widths and offsets. But otherwise, I can safely say this car should hang with a 458 Challenge EVO around a circuit when we're done. Or better yet, maybe it will blow the doors off of one considering we're going to have a few hundred horsepower more, and it's going to be quite a bit lighter. Now, to recap some advantages and disadvantages here, as said, the upshot to these control arms is that they are available off the shelf. I don't have to make replacements or spares to carry with us. These are readily available. But one major downside is that it costs a lot of money to have spares on hand versus being able to just make our own. On top of that, if I want to maximize performance, there's probably a lot of value in replacing these factory bushings with things like spherical bearings or solid bushings. Realistically though, I do want to retain at least some sense of streetability here, so right now I'm leaning towards just using the Ferrari parts. They are here, they are done, they are solved, and they work. They're gonna do the trick, no guesswork involved. They're also pretty lightweight. Everything here is aluminum. I'm gonna have trouble doing better myself. When it comes to the uprights, the only real downside with them is that the bearings are not serviceable. It's why I have these. They were due for replacement. And if I want to replace the wheel bearings in the future, I'm going to have to buy 4 brand new uprights. So one goal that I have is to 3D scan these and then perhaps make billet ones with serviceable bearings in the future. We're going to touch upon that later in the episode. But with all of these Ferrari parts, it begs the question, what are we going to do about our coilovers? Well, for that, we're going to need to take a trip back to September when we went to Germany. Now, if somehow you missed the 3rd episode of this F40 build series, you're gonna want to go back and watch it because we flew to Germany in order to buy our F140 GA V12, pulled out of an 812 Superfast. It was a once-in-a-lifetime trip for me and a whole bunch of friends, and we documented the entire thing. I touched upon some of our stops because we got to see some really cool stuff, but what might have been one of my favorite of the entire trip is the fact that we went to Lennestadt, Germany to visit our friends at H&R. H&R has been my longest supporter, and these guys are like family to me, so there was no way we were going to go to Germany without stopping in to at least say hi. But they were kind enough to roll out the red carpet for us and start the process of talking about F40 suspension.
Now, of course, if we're coming to Germany to buy an engine, we've also got to stop by our friends at H&R and talk about suspension. If we're building a custom crazy tube chassis, we're going to need some special components for it, so let's see what they can draw up.
Now, if somehow you're living under a rock and have no idea who or what H&R is, H&R was founded in 1980 by Werner Heine and Heinrich Remmen. And if you couldn't tell by the names, yes, it's as German as it gets. H&R is 100% German-made. They specialize in all things suspension, from lowering springs to coilovers to wheel spacers to sway bars and everything in between. And there's a reason I've worked directly with them for more than a decade. Not only is quality paramount to everything, this is a family-run company, and these families are true automotive enthusiasts. They are the real deal. They have supported every project that I have undertaken ever since I got started with this career, and thus they are the first I turned to when I said, hey, I want to build a crazy F40. Now, some of you might be wondering, okay, what's this got to do with me as the viewer? Well, good news, while we're here, we get to go on a full tour of H&R's manufacturing facility to see how everything is made. And if that doesn't sound incredible to you, you are on the wrong channel. But if you have ever wanted to see how springs and sway bars are made, well, buckle in, here we go. What you're seeing here is round steel stock. This is where a spring begins. Each of these giant heavy coils is a different spring diameter. These can be wound through a spring-making machine at different tightnesses in order to make different spring rates. The machine that actually makes the springs is really cool to watch. It uses a series of presses and dies, all at specific measurements, in order to force the spring into shape. I can't imagine what the math actually looks like, or at minimum the calculator used to figure this stuff out, but as you can see, these are non-linear springs. They have a progressive rate, and that means the arms of this machine are moving as each coil is spun so that it can actually accomplish this job. If you don't know a lot about springs, that might sound kind of confusing, but there is an entire Spring 101 write-up on the StanceWorks homepage if you want to check it out. Now, most of us will know H&R for making springs for cars, but they do make springs for a lot of other stuff too, including medical and industrial applications. They're equipped to make springs of every size, including the biggest springs I've ever seen in my life. Once the springs are ground down on the ends to flatten them, they are sent through a shot peening process, and from there, there's a lot of quality control steps to make sure that everything passes muster. Things like desired spring rate are measured and confirmed before anything gets sent out. From here, they move on to another building for actual finishing. All of the powder coating for their springs is done in-house, and of course it's held to a meticulous standard that is also rigorously tested. These springs and the finishes need to hold up to more than just the challenges of driving. They've also got to handle things like snow, ice, and salt. After color is set, any touch-ups are performed where the springs were actually hung, and then of course, all of the identification markings are applied. Things like serial numbers, part numbers, anything that could be needed to identify a spring and when it was made for quality control purposes and for identification. Now, that is the most simplified version of the process. We could talk about it all day, but from here, we're moving on to sway bars. These two look simple on the surface, but the amount of effort involved in actually pulling off sway bars for practically every application under the sun is incredible. Unlike the springs, though, sway bars begin their life as straight bar stock. Of course, it has a given spring rate, but that straight stock is passed through a machine that then bends it through CNC programming. This process is a lot more hands-off than making springs, but it was still interesting to watch as each bar was tested through fit, no-fit gauges to pass quality inspection. We had joked that we expected to find a room of massive German bodybuilders that hand-bent these things, but watching the machines in action was just about as cool. Depending on the application, the ends of the sway bars are then heated to red-hot temperatures before the ends are pressed flat and holes are punched in them. This is, of course, so that end links can be mounted. The finishing process and operations for sway bars mimics the springs. There's nothing else different there. Depending on the application, they're suspended and then given all the same treatments so they can hold up to the elements. And then, of course, beyond sway bars, there's dampers. This is where we're going to get a first glimpse at the parts we're going to make for our F40. Now, of course, we've got a lot of engineering to do before we can actually build dampers and design springs to go on them. But it's cool to see the parts and pieces as these are built in-house at H&R. We used these same parts on the Model A and the 244 GTK, so I know we're in good hands when we want the F40 to handle perfectly.
Now, my hope in this episode was that we were also going to 3D scan the bottom side of a 458 Challenge car so that while we have all of this information, we also have the pickup side, which is what we're going to transpose onto the F40 chassis. But our plans kind of fell through. So this episode, admittedly, is just show and tell. But we do have some 3D scanning to do. I want to get these parts 3D scanned so we can put them into our big F40 master file. I'll show you what that looks like. And then we're going to be ready for next week in the next episode when we actually get that scan done.
Now, of course, we're starting our 3D scanning process by applying markers all over the part. If you aren't aware, these are so that the 3D scanner can locate itself in 3D space and doesn't lose tracking. For this scanning process, we're going to be using Creality's new Raptor Pro. This is a handheld 3D scanner that packs a ton of punch for the price point at just $1,700. Not only is it an NIR scanner, it also utilizes blue laser lines, which can be used in a 22 cross or 7 parallel configuration. That might sound complicated, but this machine is incredibly easy to use even for a beginner. It's accurate down to 0.02 of a millimeter and can scan anything from small parts on a workbench all the way up to a full-sized car. This is a powerhouse, and I'm excited to have it in our toolbox. The scan for these parts only took around 10 minutes apiece, and that was taking my time. Tracking loss was nearly non-existent, and when it did, it was able to find its position within a second. This was one of the smoothest scanning operations I've undertaken, so I can highly recommend this tool for anybody else looking for one. It also does full color mapping if that's something that you're looking for. I'm currently running it in a wired configuration, but you can also pair it with the scan bridge if you want to go completely wireless, turning this into an insanely powerful tool. If you're interested in a Creality Raptor Pro, be sure to check the link in our description or in the pinned comment. You're going to want to check one of these out. I cannot recommend this stuff enough. This is easily one of the most powerful tools we have here in the shop, and it's making a project like this F40 possible, but you don't have to be building an F40 to utilize something like this. This is a game changer for automotive projects or fabrication of any kind, so hit that link, and thanks again to Creality for sponsoring this segment of the video.
Now that is where this episode is going to end. I'm really excited to have these parts, and I know that this episode was mostly just show and tell, but so many of you guys have been really supportive about the deep dive and the details on this series so far, so I'm hopeful you guys are as excited as I am about this stuff. And once we have the 3D scan of that 458 Challenge car, so that we have all of the information to pair with these parts, we're gonna be able to start designing aspects of this chassis and start getting it built much more rapidly. Not to mention we're working on all sorts of stuff behind the scenes, but we need a little bit of time to get there. So between that next episode and this one, we're also gonna be working on the 244 GTK. We've got some huge updates in store for it. I've got a really big piece of news I'm excited to share. The Patreon guys know most of everything that's going on. So if you want behind the scenes content, go to our Patreon page. I try to make sure that we update it frequently with just cool stuff that we're doing that doesn't make the cut for the channel or is just really early. And last but not least, I just want to say thank you to all of you that watch this channel, that watch these episodes, and that let us do these deep dives on this kind of stuff. We're having a blast. I hope you guys are too, and we'll catch you in the next one.